Hello everyone, and thank you for attending our webinar. Today I will show you how you can use ONE AI to implement your own AI-powered quality control application. My name is Christopher and I work as an AI developer at OneWare. In that role, I mainly work on improving and expanding the capabilities of our AI generation tool. But I also take care of technical support questions. So if you have any questions, feel free to send me an email. And with that, let's get started. First of all, this webinar is being recorded so that you can rewatch parts of it later on. We will have a round for questions afterwards when I've stopped the recording. Today's webinar is divided into two parts. In the first part, I'm going to explain you what ONE AI is and how you can use it to create your own AI models. I'll also show you a few tricks for creating good data sets, and I'll show you how to use OneWare Studio Live with a demo use case. Then, in the second part, you have the chance to try it out yourself, and we will provide you a demo data set, and with that you can train your first AI model for a quality control application. And with that, let's get started. So, what is ONE AI and why should I use it? Well, if you if you are trying to create an AI model for some application and maybe already started reading about it, you might have come upon some or quite a few standard models that are designed to handle a wide range of tasks. But if you tried one of those models yourself, you might have also noticed that it only produces mediocre results for a lot of tasks. And that is because those models are quite large and universal. They are designed to handle a wide range of problems. For example, a common data set that is used to train those models is the cocoa data set. And here you can already see the same model is expected to both detect fruits, but also detect cars in the traffic scenes and many other things more. But on the other hand, your problem might be a lot more narrow. A lot of problems only focus on one single task, for example, detecting scratches on coffee mugs. And yeah, they only try to detect one type of class, and all the images look quite similar. And because the difference between those types of problems, those standard models that are quite universal, don't work that great on narrow tasks. So, how would you approach to develop an AI model for your own task? Well, one idea is to hire an AI expert that does a lot of research and develops a model for you. After some quite amount of training and testing models, they might produce a model that works great, and then it's time to integrate that model into your existing pipeline. But to do so, there might be quite a bit of work left to do because the model needs to be optimized to fit on the existing hardware. And maybe you even need to buy more additional hardware that is more powerful and can handle the demands of the model. And then that hardware needs to be integrated into your existing systems. And until you have a working solution, it takes weeks, if not months. And this is where ONE AI can help you. With ONE AI, you can automate the whole of a lot of this process. All you need to do is provide your data set and the context of your application. That is enough for ONE AI to create a custom AI model that is fine-tuned to your application. And we also take into account the hardware that you want to use so that it's easy to integrate it into your existing system. And the best of all of it, you don't need to be an AI expert to train a model with ONE AI. And our results speak for themselves. With our partner Altera, we developed a demo for quality control in a for a production line that produces potato chips. And the task was to divide burnt potato chips from normal potato chips that are suitable for consumption. And we created an AI model that is able to run even on old hardware, a 10-year-old FPGA chip in that case. And we were not only able to create a model that runs on that hardware, but it was even a lot faster and more accurate than one of those existing standard models that ran on the latest NVIDIA hardware. So, if you've taken a look at our website, you might have seen that we talk about a few different software components and might have wondered what's the difference between all of those. So, let me explain it. First of all, we have ONE WARE Studio. This is our open source software for PGA development, but also AI development. And it's quite modular and offers support for quite a few different extensions. One of them is our own ONE AI extension. And this can be used to configure and create AI models directly in ONE WARE Studio. Then we have the ONE WARE Cloud. This is our cloud service that we offer to you so that you don't need any beefy hardware to train your models because you can simply, all you need to do is configure is to install ONE WARE Studio on your laptop and configure the model, and the computational intensive training is done on our servers. Then finally, we have ONE AI. This is our software component that handles everything in the AI creation, training, and exporting process. And this component runs on our cloud. If you have some sensitive data and need an offline solution, that's also possible. Please contact our sales department for that. Well, first thing that you need for creating an AI model is a data set. And because there are some things that you should look out for, I'll start with giving you a few tips and tricks on how to create a good data set. So, the first thing that you should look out for is to record representative data that is representative, that is as close to your deployment conditions as possible. For example, here on the right, I intentionally created a data set that wasn't representative. And all I did was record cups, and they were all on the same plain background. And this approach worked good for the training data. But if I then change the background and have suddenly background that is new to the model and more busy, we start running into problems. For example, here you can see that that the model predicted an additional print on the top here where there is none. So yeah, to get predictable results, you should watch out that your training data is close to the real deployment conditions. Then you should also take care to provide enough data. In general, you can say the more data your model has for training, the better. Unfortunately, I can't give you a single number that works good for all cases because there are quite a few different factors that change the amount of required data. For example, if you have a more complex task, you require more data to train a model that is able to handle the task. The same is true if you have quite diverse objects or backgrounds, or even if you have a large number of classes. So the amount of training images that you need can start at just 50 images per class, but can go up to a few hundreds or even in the thousands. You should also try to capture varied data. If you give the model 100 images that look almost identical, well, can't learn a lot from that. The next thing that you should watch out for is to label your data correct and consistently. For example, here on the right, we have a task where we want to detect strawberries and also foreign objects. But if you look closely, you see, well, we missed a strawberry here. And this is actually a problem for the training because at the end of the day, all the model is a set of rules. And during the training process, we try to update and fine-tune those rules to match the training data as close as possible. But if you have a missed object, then some of those rules try to capture why this object shouldn't be labeled. So not only does the model not predict some of the strawberries in the deployment conditions, but it will also waste some of its capabilities to distinguish between this strawberry and this strawberry to learn why this one should be labeled, but this one should. And that's not something we want. So you should take care to label all objects that are visible on all your images. And then you should look out for the quality of the labels itself. For example, most labels are quite good. They are fit snugly around the objects. But here we have a box that is quite loose. There is quite a bit of margin between the object and its box. And well, if the data isn't labeled well, the predictions won't be good either. And then finally, you should watch out to take a small part of your training data set and keep it separate. We do this because the model will perform best on the data that it was trained on, simply because all those rules were updated to represent the training data as close as possible. But this also means that if we want to do a reliable evaluation, we can't use that training data. And that's the reason why we take a separate set for testing our models. This is also quite important to detect overfitting. Overfitting happens when your model starts to memorize the training data instead of just learning the underlying rules. And what happens can be seen here in those training plots. In the balanced fit, what we want to achieve, we see that both the mistakes made on the training data set, the red line, as well as our validation data set decrease over time. But on the other hand, here in the overfitting case, we see that the mistakes on the training data become less and less and less. But there's some point where the mistakes on the validation data starts to increase again. And that's exactly the point where the model starts forgetting the general rules and memorizes the training data. Maybe a good analogy is when you try to learn for an exam yourself. If you only learn the questions and their corresponding answers, you will probably perform quite bad in the actual exam because as soon as a new question pops up, you can't answer it because you never learned the underlying rules of the material. And it's quite similar for what happens when a model is overfitting. So now that you know what to look out for creating a good data set, let me show you the data set that we will be using today. We created a small data set of our ONE WARE coffee mugs. And the goal for this demonstration is to detect the logo that is printed on them. This could, for example, be used for a quality control application, where you try to detect whether the logo was printed on the correct part of the cup. Or it could be extended to detect different logos and see whether the correct logo was printed, or maybe even check whether there are any printing mistakes. To show the capabilities of ONE AI and make things a bit more interesting, we try to challenge ourselves a bit and try to solve this problem with only a very small data set of just 25 images. And as an additional challenge, we also used quite busy backgrounds that changed quite a lot from image to image. So now let's switch to ONE WARE Studio so I can show you how to uh, how to get started and create your own AI model. So this is how ONE WARE Studio looks when you get started. I've already have everything installed. So the first thing I'm going to do is create a new AI project. For that, I open the project generator. I want to, I don't have an existing parent project. And for the name, well, let's go with webinar demo. So this creates and opens a new project. The first thing that I need to do is load my training data. I have the option to simply drag and drop image files or load image files if I only have the image files and no labels yet. And if I'm not even there yet and still need to record data, I can do this in ONE WARE Studio too. We have our camera tool here, and here I can add a new camera. And once it is loaded, I can use it to capture new images by simply pressing capture. And this has the advantage that it works on multiple cameras and presets simultaneously. So you can capture 4 or 5 or even more images with one click. Oh, oops. But as I've said, I've already recorded the data set, and so let's use the dataset import to load that data set. Here we can simply select the directory. Here I have the print detector demo, my dataset, and I select that folder. Then I need to tell OneAI which format my dataset uses. We support quite a few common formats for both classification and object detection programs. This dataset is recorded, uses the COCO dataset format, so let's use that. And with that, all my images are imported. You might have also noticed that the mode here at the top here changed from classes to objects. If we choose to predict classes, all images just have a single class. But in this case, we don't just want to have one class per image, but we actually want to detect the objects and where they are. So I changed this to objects, or leave it at objects. One nice thing is we have those question marks all over or everywhere in our software. And if you don't know what a setting does, you can simply click on it and add a short explanation that will help you figure it out. So I mentioned that you can also label data in ONE WARE Studio. For that, you simply click on the image. And I actually left the first two images unlabeled, so I can show you how it works. I click on the rectangle tool, and with that, I can draw a box on my image and select the label. Then I can move it around, maybe put it a bit more snugly around my object. Then I press on save and go to the next object. Then let me again draw the box. And if you don't have any labeled data, this is what you would do for all the images. But for the sake of time, I already labeled the other images so that we can continue. You might have noticed that at the top here, we have a few different tabs. First of all, or as I've explained before, we want to split our images into subsets. And we have one additional set here in ONE WARE Studio. And well, let's go through the different sets and see what they do. First of all, we have the training data set. Those are the images that your model will be trained on. Then we have the validation data set. The validation data set is used to optimize parameters. For example, the size of the model or also control the training progress itself. If you don't have any splits, you can let ONE WARE Studio create them for you. And this is actually the standard setting. But since we already have an existing data set split, we turn that off. And finally, we have the test set that is reserved for doing a final evaluation to see how good your model performs on new data. And since we also have a test split, I also turn this down as well. Then next we have the hardware settings. As I've explained before, ONE AI takes your target hardware into account and is able to create a model that fits on the target hardware. And to do so, one AI needs to know some specifications for your hardware. We have a list of pre-configured hardware, and you can select one of that by opening the configuration dialog. Here you can select between a default CPU, GPU, and TPU, and you are also able to install additional support. For example, here I have the Altera Max 10. But for today's demo, well, keep it at the default CPU. If your hardware, or if there isn't a pre pre-existing configuration file for your hardware, don't worry, you can also specify the settings yourself. To do that, you click on Advanced, and here you can specify all the settings for your hardware, for example, the compute capability or the memory limit. And this also changes between different hardware types. For example, if I switch to an FPGA, I could also uh, specify some FPGA specific settings. But as I've said, for this demo, we are simply using the default CPU. So I'll just set it to that. The next two sections are filters and augmentations. Those actually work quite similar. And to explain what they do in detail, let me switch back to my presentation because I've prepared some slides to explain it a bit better. First of all, we have image filters. The goal of filters is to prepare the images for training the model. For example, we want to remove unnecessary information. So we could apply a color filter to our images to reduce the saturation to 0 and convert the color images to a grayscale image. Or another example would be scaling down the images so that we have less information that isn't really necessary. Then we might also use filters to improve the visibility of objects. For example, here we've increased the contrast to make the logo a bit more visible. The key part is that these changes are fixed and are the same for for every image. And this is in contrast to the augmentations. And we use augmentations to increase the variation in our training data. And by doing so, we can actually increase the robustness of the model. So what do we do? During the training process, we randomly alter the images. For example, here on the right, I have a color augmentation that randomly either reduces the brightness or increases it. And by doing so, I can generate additional data without needing to record or label any new images, which might be quite time consuming. So let's get back to OneWare Studio and see what filters we are going to use today. First of all, we have the begin section. Here we have first the initial resize. This is for our models work on a fixed image size. And if you have images in your dataset that are of different sizes, you need to first bring them to a common size. And for that, we use this initial resize. And here you can set the width and height of the image that you want to use. Afterwards, we have the resolution filter. With this, we can change the resolution to, for example, 50%. Or in this case, since we have quite a high resolution, we can turn it down even more. And my recommendation would be reduce the resolution as much as possible, but keep in mind that your objects still need to be visible. So for example, in this case, we can go down to just 5% of the original resolution and are still able to reliably see the logo on the cups. And reducing the resolution is quite important because if I still had the full resolution, my network would need to analyze quite a large amount in the image. This will be multiple hundred pixels wide and high. But if I reduce it to 5%, we have a lot smaller area that needs to be analyzed, and this makes it easier for the model to detect the objects. Then we have two other sections. First, filters that are applied before the augmentations, and then filters that are applied after the augmentations. For example, something that we want to apply before the augmentation would be a crop filter, because, well, first of all, the augmentations work on a smaller image, so they are faster, and the image might move during the augmentation, so it's important to crop the images first. But for this case, we don't have a fixed area where the cup appears, so unfortunately, we can't use a crop filter. And in the after augmentation, here I do filters that are applied, as the name suggests, after the augmentation. So for this demo, we are going to use the color filter. And as I've already said, we have colored images, but since our tabs are black and white, we don't really need that color. So to simplify things, we can just turn the color down, the saturation down to 0%. I've fiddled around a bit with the settings, and I've noticed that if we increase the contrast a bit and turn down the brightness, the logo becomes a lot more visible. One thing that is important here is that you should look out that the filters that you are applying work for every image and not just the one you're looking at. So I recommend to switch the image from time to time to see whether your filter works for every image. Otherwise, you might have added a crop filter and tuned it to that one image and then realize, oh, if I switch to the next image, it doesn't work anymore and it cuts off part of my object. Then finally, we have the channel filter. This one can be used to remove certain channels. For example, um, our images consist of three color channels, red, green, and blue. But since we converted our images to grayscale, we don't need all three of them. And it's enough to keep one of those channels and we still have all the information left. So let's disable two of them so that the AI model has less unnecessary information. Then the next part are the augmentations. Here we already have some pre-configured augmentations that already work good for most applications. First of all, we have the move augmentation that slightly moves the images left, right, up and down. And this has the advantage that the AI can't learn that all my objects are always in the middle. But what we actually want to do is learn that those can be on any part of the image. So by moving the image around a bit, the model becomes more robust. And the same actually goes for rotating the images a bit. And since we have, since we want to detect the logo in any rotation, I'll just go from minus 180 to 180 here, so that the image can have any possible rotation, and our model is still able to detect the logos. We also have a flip augmentation that can be used to mirror the images horizontally or vertically. This isn't actually applicable for our task because, well, no matter what I do, there isn't a case where I encounter a cup where the logo is mirrored. So I'll turn this one off. And then we have the resize augmentation, which scales the images up and down by a tiny amount. And keep in mind, this isn't a single static thing, but uh, all those values are chosen randomly during the training. So for one training step, my images might be scaled down, and for the next, they might be scaled up. Then the next thing we have is the color augmentation. This one slightly changes the color of the image and can be used uh, to simulate different lighting conditions. We can leave this one at default values. And if I want, I can add even more augmentations. So maybe let's do a noise augmentation to generate some amount of camera noise and be sure our model still works if we have a bad camera sensor. The next thing that we need to configure are the model settings. In the model settings, we have two different kinds of settings. First, we have the output settings. Here we specify how the output of our model should look. For example, I can change it from predicting the size, position, and class of object to only predicting to the position in the class. This might be useful if I have a fixed camera position. For example, all my objects are on a conveyor belt and I already know what size they are. I'm only interested in the position. So I actually can save the computations that would normally be used to compute the size and instead use them for the other tasks in my network. Or I could go even further and change the object detection task to a classification task. But for today, we want to simply predict the size and position of the boxes, so we leave it at the default. Then we can also specify the amount of resources that we want to use. Let's go for 25 frames per second for this demo and maybe increase the memory usage a bit, since we aren't really memory constrained. The next thing that we need to specify are the input settings. Here we give ONE AI a bit more context information about our application. So, for example, the first thing that we need to do is estimate the area that the network needs to analyze to detect small objects and large objects. For our task, this is simply the logo itself. But there are other applications where it might be necessary to also look at some parts of the surrounding area to detect things. For example, if you have PCB and want to detect whether all components are installed correctly, well, you can't simply just look at the components itself, but also need to look at parts of the surrounding circuit board. So in that case, the estimated surrounding width would be larger than the object itself. So for our task, let me look into my notes. Yeah, um, I looked at the data set and the smallest logo take up roughly this amount of space. We also have a visualization here at the bottom. And then I also need to specify the space that is taken up by larger logos. So when the cup is closer to the camera, and that is a width of about 40% and a height of about 30. The next thing that we need to estimate is the difference between two images or two objects of the same class. So, for example, here we have two images, both show cups, and we notice, well, our logos look quite similar between between the two images. So we can turn this down a bit. Let's go with 20%. And then we also need to give an estimate of how diverse the background is. As I've said, and maybe as you've seen before here in the training data, we have quite a wide range of backgrounds. So this would be quite a bit higher for our task. Let's go with 75%. And the last thing that you need to configure is uh, the overall complexity of the task itself. Since we are just doing a demo today, we chose a problem that isn't that complex. Let's go with 75% for this as well. And with that, we have everything configured. The next thing that we need to do is actually train our model. And for that, we synchronize ourselves with the OneWare cloud. For this, you need to be logged on, which I currently am. So I can press on sync. Then you see you have an empty list. That's because you first need to create a model. Let's call it just first. And this has the advantage that you can train and create and train multiple models and change the settings in between and compare how they perform. So to train a model, we have a training button at the top here, and here we can configure the training settings themselves. First of all, we have the maximum time that we want to train the model. 15 minutes should be good for this one. But if we are not sure, we can also use a feature that's called early stopping. What this does is it monitors how our model performs during the training. And if it stops improving, then, well, maybe it's already trained and we can stop the training early. We need to set a percentage range for this, and this is simply the percentage of the training time. So, for example, if I set it to 50, oops, if I set it to 50%, then if the model doesn't improve for half my training time, so 7.5 minutes, then the training is stopped early. The next thing that we can enable is quantization optimization. First of all, quantization is a process to improve the model performance. To do so, it converts the actual parameters and computations of the model itself. Normally, we use floating point values. And instead of that, we convert our model to use 8-bit integer values. And because of that, the model becomes a lot smaller and a lot faster. And this is especially important if you plan to export it later on to, for example, a microcontroller or an FPGA. In that case, you actually need to turn this on. Uh, but the disadvantage of that is um, that you have a small loss in accuracy. But to mitigate this, you can enable this quantization optimization, which uses quantization-aware training to still get a good quantized model. Since the quantization-aware training is a bit slower, it is recommended to first start with normal floating point training and to optimize for quantization later on. So the default value for 70% normal floating point training and 30% quantized training is a good trade-off for most tasks. But since we don't want to export our model for an FPGA, we don't need this for today. And with that, we can start a train. Since this would take quite a bit of time, I'm not going to do this right now. Instead, I've already prepared the same data set and already trained the model, so I can show you how it looks. First of all, we have the training logs. Here you can see some general useful information. For example, we can see how many parameters my model has, and if there are any problems that occur during the training. For example, if there is an issue with the dataset, it wasn't imported correctly, you will receive a warning here. And then we have the statistics tab that gives us a live update, live training curves, how our model performs during the training. And if we notice that the progress isn't to our liking, we can stop training early. After the model was trained, the next thing we would do is test the model. Normally, we would do this all in the same model, but since I wanted to show the different logs, I've actually duplicated the model to have multiple models to show this to you. But normally, you would only have a single model. So to test the model, we would press the test button. We have a few settings, but in most cases, the default settings are a good first approach. And then you'll see in the logs the statistics of the training. In this case, we were able to achieve 100% accuracy, but we also see a slight caveat. We only have a total of 5 test images. So since the test data set is quite small, uh, those numbers might not be that representative. If you want to have accurate results, you should use quite a few more images. And we can also look at those results in the cloud. And I'll show this here. So this is how it looks, where you actually have a few example images on how on what was put into the model here on the left, and what the ground truth label is, as well as the predicted label. Yeah, and so you can use this testing capability to look for any cases where there might be problems and things that you might still be able to improve. And then the final step would be exporting the model. For that, we click on export, and we actually have quite a few different formats that we support to make it easy for you to integrate the model on your existing hardware. The most general format type is the Onyx model. And this is the one that I also used for this demo because we actually can load an Onyx model within OneWare Studio, as I will show in a bit. If on the other hand, you want to export your model to some kind of microcontroller or FPGA, you would select project, and then we already have the first setting exported as a VHDL model to an FPGA. But let's stay at once. Then another neat thing that is already turned on is that we by default export the models already with the pre and post processing layers. This means that all those pre-filters that we configured a bit ago are already baked into the model. So you don't have to take care to implement them yourself. All you need to do is put the image into the model and you get the results. So after we've pressed on export, we see that in the logs that everything ran through, and then we can go to the export tab to download our model. I've already done so, so I don't need to download it again. And well, now let me show you how you can actually use the model in OneWare Studio itself. So one thing you can use the model for is to help you with your labeling efforts. To do so, we go back to the Dataset tab and go to the annotation tool by clicking onto one of the images. Here in the top, we have this AI button. And here you can also see the model that I've trained. And by adding the model, we can use it to help us with labeling our data. We can also increase the confidence that the model needs to have. This would be useful if we notice that we are predicting too many labels and there are too many false positives. But for most cases, the default confidence uh, is good. So let's say I don't have a label for this image yet. What I could do is press the AI button and it uses the AI model to automatically create the label for this image. In this case, I would still need to fine-tune it a bit to make it tighter, but if you have many objects, this might still save you quite a bit of time. And you can also use this to just go through your data set and see where the model performs good and where there might be problems. So if I just go through a few of those images, well, maybe not use the train data set, but actually the test data set, I can see whether the model is able to find um, uh, those logos. And as we can see, everything works as intended. You might notice for some cases there is still quite a bit of margin between the predicted box and the actual logo. This is mainly because we have quite a small training data set. If you had a large training data set, this would already also improve with the size of the data set. Another thing that we can do in OneWare Studio is actually get a live preview of our model. And for that, let me go back to the camera tool. Let's re-add the camera. Okay, let's choose the model that I want to use as well as the camera. And then I can press on play. Yeah, you can see once the camera is in focus that we are able to detect the print on our cups on this live data.